Hello and welcome back. In the last session, we looked at some of the common issues that you can encounter when working with Git and how to fix those issues. So, we looked at the detached head state. We looked at how to fix the accidental git reset -- hard command. We also looked at how to troubleshoot the push and pull errors. And in addition to this, we also looked at how to fix the Git authentication errors. Now, in today's session, we are going to cover 4 essential security practices on GitHub. In today's world, security is not an afterthought. It's a fundamental part of your development process. As developers, we are responsible for not only writing great code but also for protecting our projects and our credentials. The good news is GitHub provides us with a robust suite of tools to help you just do that. Today, we are going to talk about 4 essential security practices on GitHub using the right authentication, enabling two-factor authentication, and leveraging automated tools like Dependabot and code scanning. Let's get started with this. First, let's talk about authentication. Specifically, let's talk about SSH and personal access tokens. For a long time, many developers used their GitHub password for Git operations over HTTPS. However, if that password is compromised, your entire account is at risk. A much better approach is to use SSH keys or personal access tokens. So let's talk about your SSH keys. I have already covered how to set up your SSH keys. Under this, basically what we do is we generate a SSH keys, which will be your public key and private key. So here, for example, this is my private key and this is my public key. Now this private key stays securely on your machine, and then we use this public key and upload it to GitHub. Like here, I can go to my GitHub account. I will go to settings, and under this you can see SSH and GPG keys, and here you can see my public key. So now we can authenticate by providing this private key, so you have never have to type your password or store it anywhere. That's your SSH keys. And then you have your personal access tokens or PAT. A PAT is a long-lived alphanumeric password that you can generate in your GitHub settings. So here you can, under the settings, you can go to developer settings, and here you have the option of using this PATs. So you can generate this and you can use this for your authentication. Now the key advantage of a PAT is that it has granular permission. So whenever you're generating a new token, you can control the permissions at a very granular level. Like you want to give access to workflow only, which is your GitHub actions only, or for notifications only. So you can control those permissions. So you can create a token that can only read issues or only push to one specific repository. If this token is compromised, the attacker cannot access your entire account. Now, the recommendation is that for daily command line Git operations, SSH is the best choice for its convenience and security. For scripting, automation, or third-party services, PATs are the superior option because you can limit their permissions to exactly what is needed. So that's about your first essential security practice. Now, let's talk about two-factor authentication, also known as 2FA. Now, if your password is the lock on your door, two-factor authentication is a second separate lock. It's an extra layer of security that requires 2 forms of verification to log in. So basically how this works is, after entering your password, you'll be prompted to provide a second piece of information, such as a code from an authenticator app on your phone, or a physical key, or a code sent via SMS. Now, why is this crucial? So this is very important because even if your password is stolen, an attacker cannot access your account without that second verification method. So how to set it up? And under this, you can find this password and authentication, and this is where you can enable your two-factor authentication. So let's go ahead and enable this. So click on enable two-factor authentication. Now for this, you will need to use an app. So in my case, I'm using Google Authenticator. So I'll open up the Google Authenticator app, and we will need to scan this QR code. So let me quickly do that, and this will generate the code for me. So here I'll enter the code that I have on my mobile device, and this is something that you can use in case you lose your device or you don't have access to your device, you can use this to recover your access. So you can download this, and I have saved my recovery codes and then done. So this is how you can set up your two-factor authentication. Now, how this works is, let's sign out. So let me sign out from here. We'll sign in again. We'll use the account. So in addition to the password, this will prompt me for the two-factor authentication. So now I will enter the new code that I have, and this will log into my GitHub account. So that's how you can use your two-factor authentication to log into your GitHub account. So in addition to the password, you'll also need to enter the code to log into your account. So this is one of the single most important security step that you can take to protect your account from unauthorized access. And this is something very commonly followed at an organization level. So if you're working in a company and you have a GitHub account, then for sure you will have this SSO enabled, or you might be using organizations, which I'll be covering in the upcoming session. Now let's talk about automated security with Dependabot. Now, managing dependencies for your security updates and vulnerabilities is a never-ending task. Fortunately, GitHub provides us with a built-in tool called Dependabot to automate this. So Dependabot will automatically scan your project's dependency, and it will create a pull request to update them to their latest versions. This helps you to stay current and avoid conflicts. So let's say, for example, if one of your dependencies has a known security vulnerability, Dependabot will immediately send you an alert. If a fix is available, it will automatically create a pull request with the fix, making it incredibly easy to patch. So let's see an example for this. So we will use this collaboration project for our demo. So let's say here I will create a new file. Let me call that as package.json, and this is the content of the file. Now here you see this dependencies. I'm using Express, and this is the version I've defined. Now this is a vulnerable version. I know that. Now what we will do is we will enable Dependabot for this, and we will see it in action. So what will happen is Dependabot will scan this file, it will get this, and it will know that this is vulnerable, and it will automatically create a PR for it with a fix telling, hey, you need to update this, and it will also give me the version that I need to update. So let's go ahead and commit this. Let me directly commit it to the main branch. You can also do it on the local and then push it, but just to save some time, I'm doing it in the UI itself. Now, how do you enable Dependabot? So you can go to the settings of the repository, and here go to advanced security. Under this, you should be able to see Dependabot, and here you see this Dependabot security updates. We are going to enable that. So yes, enable, and done. That's all. So now Dependabot will start scanning my code, whatever I have in this repository, and if it finds a vulnerable file, it will automatically create a PR for me with the changes that are needed. So this may take a minute or so, so I'm gonna wait. The Dependabot seems to be taking more time than expected. I already tried this earlier, so this is what it should look like. So here, for example, if you see, so this was 2 days ago that I had created. So it's the same code that I used, and this is basically what you should see. So the Dependabot will scan your package.json file. It will analyze your code, and it'll tell like, hey, this is a vulnerable version, you will need to upgrade it to this particular version, and this will also automatically update the code as well. So here you can see it is automatically updated. So all you have to do is just review this code, test it out, and go ahead and merge these changes. That's all. So that's basically what your Dependabot does. It helps you to automatically scan your code for any vulnerabilities, and then it will automatically create a PR with the fix so that you can review the code and then just apply it to your environments. So Dependabot is a set it and forget it tool that continuously monitors your dependencies, saving you from having to do it manually. The last thing that we are going to talk about is code scanning with GitHub Actions. While Dependabot secures your dependencies, code scanning helps you find vulnerabilities in your own code. So how this works is, this is typically set up as a GitHub action that runs every time you push your code or open a pull request. So basically what this does is it uses powerful analysis engine like CodeQL to scan your source code for common security flaws such as a SQL injection or cross-site scripting or any other vulnerabilities. The results are then reported directly in your pull request, providing you with detailed information on how to fix the issue before it's ever merged. So let's see an example for this. So here, let's say I'm going to create a Python script. So let's call this as a vulnerable script. And this is what I'm going to have in the script. So in this code, we have this security vulnerability where we are using a weak hashing algorithm, which is this basically MD5. So let me commit these changes. We'll do it directly on the main branch. Okay, looks like I already have something. Let me check. Okay, looks like I already have this script. Yeah, it's the same script. So we will reuse it. So we have the file here. Now we will set up our GitHub actions for this. So let's go back to this .github workflows, and here we will create a new file. And let me call this as CodeQL analysis.yaml, and this is the code. So we are giving it a name. We are looking for the main branch, and whenever there is a pull request for the main branch, so we want to analyze our code. We are using Ubuntu as our runtime, and we are giving it the necessary permissions. So we are using the CodeQL to basically scan our code, the Python code that we have, and give us the result. So that is what this GitHub actions is gonna do for us. So let me commit this, and we will see this in action. And done. So let's go to the actions tab, and this should trigger my CodeQL analysis, and this will tell me if there is a vulnerability or if there is any security issue with the code that I have written. So this will basically scan all the files in my main branch and then give me the result. So let's wait for this to complete. So currently this is analyzing, so you can see perform CodeQL analysis. So this is now scanning my files and looking if there are any security issues with the code that I have written. So let's wait for this to complete. So once your GitHub action workflow completes, you can head over to this security tab. Again, for some reason, this is taking time to publish the results. But generally, if you go to this code scanning, you under this open, you should be able to see something like this. So in my case, you can see here, it is telling like, hey, this is a sensitive data and which is using a insecure password hashing, and it is not computationally expansive hash function. So basically it is telling like, hey, this is a security risk. You're not using the secure password hashing, and you will need to update it. So you can see more details about it, and you can see the recommendation as well as to what needs to be done. And then you can go ahead and make the necessary changes to fix the issue that you have. So this is where we can make use of your code scanning with GitHub Actions to automatically scan your code. So that's about the 4 essential security practices that we have in GitHub. By leveraging these 4 practices, using secure authentication methods, enabling 2FA, and utilizing Dependabot and code scanning, you can dramatically improve the security posture of your projects and your development workflow. And that brings us to the end of the session. Thank you for watching, and I will see you in the next session.